right, here we are. So Tuesday. All right, so what do we have to do today? So we've got a few interesting things going on. First of all, we're done with the price elasticity. Hold on a second. The price elasticity of demand is done, but we have two other types to look at. And then I actually did find an interesting video about elasticity. It's hard to believe, but it's true. And then we're going to look at chapter 7, which comes next. And so let's see, where did we leave off? As far as I know, we're completely done with the price elasticity of demand. So now what came next was, there's a few things. Let's see. All right, I'll tell you what, let's review a little bit what the last bit of price elasticity of demand, and then we can move into the last two, which are income elasticity of demand and cross elasticity of demand. All right, so I think we got to this point, but I just want to remind everyone that the price elasticity of demand, as we've calculated it many times, it actually changes on a straight line demand curve. And so right smack in the middle there, the midpoint is where the price elasticity is exactly equal to 1. And we discovered that this is where you want to be pricing your product, because this is where total revenues are maximized. When we're up in this zone up here above the midpoint, that means that the price elasticity of demand is high. Okay, the demand is elastic. And when you're up here, you have an incentive to lower the price, because this increases your revenues. Okay, so as long as the elasticity is above 1, lowering the price increases our revenues. In fact, we had a chart here. Let me scroll back and revisit this chart for a second, just to remind you how this works. From the perspective of the producer, the key thing is we're trying to make money. So remember that when we have unit elastic demand, no matter what price we charge, the total revenue never changes. It's when it's inelastic, then it makes sense to raise the price. Like the Starbucks example we had, they raised the price of the coffee by 10%. And as a result, the revenues actually went up because hardly anybody stopped buying the coffee. But then it would be a mistake to cut the price in that case, because you'll just lose revenues. With the elastic case, like the computers that we looked at, it was a terrible mistake to raise the price, because then people stopped buying computers, or at least they cut back quite a bit, and we end up with less revenues. But at the same time, though, if you put those computers on sale, you should experience an increase in revenues, because now everybody wants a computer anyway, and this gives them an opportunity to buy it. So on the straight line demand curve, we have different regions with different elasticities. And so going back to this diagram, in the middle, we have 1. As we move up the curve, it goes up and up and up. Eventually, it reaches infinity when we get right here at the intercept. So that means that if we're on the upper portion of this curve, we should really be lowering the price, because that will raise our revenues. On the other hand, down here, it's the other way around. The demand is inelastic, and so that means we should raise the price, because that will also raise our revenues. Okay, and so when do we stop? Right here. Okay, so when we reach this point where we are exactly at 1, it means that we stop raising or lowering the price, because this is where we need to be. Right here, this point maximizes total revenues. If we're anywhere else, in other words, if we're charging a price below 10, we have an incentive to raise the price, because that will give us more revenues, but not past $10. If we're above 10, if we're charging, let's say $12, then we have an incentive to lower the price, because that will raise our revenues even further, but then we're not going to lower it below 10. This is where we should be, right here. All right, now, having said all that, there are a couple of cases where the demand, the elasticity rather, is constant along the demand curve. These are the extreme cases, I guess we can call them, where in one case we saw that the demand curve could actually be horizontal, and in the other case, it could actually be vertical. And in those cases, the elasticity is the same across the entire curve. For example, one more thing I forgot. Down here at the bottom, we reach the point where the elasticity is 0. So we go all the way from 0 to infinity along the same curve. And then this is where we want to be. Okay. So now I just want to remind you of the special cases. For the horizontal curve, the price elasticity is infinite throughout. And that means that if the price is increased, even by a penny, the quantity demanded will go to 0. Now that's what you call sensitive consumers. A penny, one more penny. Like imagine if you went to Starbucks and they normally charge $2 for a coffee, and suddenly the price goes up to $2.01, and every single customer walks out the door and says, "Nope, I won't pay that extra penny for the coffee." Then this is what you'd be experiencing: a perfectly elastic demand curve. Okay, so this is sometimes called infinitely elastic. Sometimes it's referred to as perfectly elastic. Now, you might say to yourself, well, you'll never see this in the real world. And that's true to a large degree, but we will be seeing this again in a later chapter. Even if it's not actually going to happen in practice, we can find cases that are very close to this. And in fact, there's a video that I found, which is quite interesting, that showed a case like this. I don't want to spoil the surprise, but let's just say it involved a small town and certain products that were being sold, and the demand for that product was more or less infinitely elastic. So we'll see that in a couple of weeks when we get to that chapter. But it can actually happen, or at least something very close to it. Now, the other extreme would be then the vertical demand curve, where there's no change in the quantity demanded at all. In other words, no matter what the price is, that's what we're going to pay. End of story. And, we've used the example of life-saving drugs. This one, yes, the price elasticity of demand is 0. This is sometimes said to be infinitely inelastic. Or perfectly inelastic. They all mean the same thing. And so what's happening here is that the quantity demanded is independent of the price. Which means literally that the price could be anything and the quantity will still be whatever this number is. So the life-saving drug is a perfect example of this because let's just say that the people in this market need Q-star units of this drug to stay alive. Having more doesn't do any good. They need this much and that's it. Having less means they die. So therefore, they're going to buy this amount no matter what it costs. And so therefore, the curve is vertical. And we say that the demand is inelastic. And so you see this, there are a lot of drugs like this where the demand is more or less vertical or it's very close to it. And so, and I think I mentioned last time that scandal with the EpiPens where the producer was trying to charge just outrageous prices for it, which they had the right to do, but it certainly led to a huge backlash in the press. And let's just say they backed down and brought the price back to something more normal. But yes, this is a case where you might have an infinitely inelastic demand curve. And then we have this other really bizarre case, the hyperbolic. Look at this thing. So the way this thing is constructed, you can't tell from looking at this curve, but what's happening is that total revenue is constant along the entire curve. All right, let me show you an example of this. So let's say, for example, at a price of 10, people buy 10 units. If the price is 5, people will buy 20 units. And you can see in both cases, the revenues are $100. If the price was lowered to 1, then people would buy 100 units. Okay, so you see what I mean? Every combination of price and quantity gives me exactly $100 as my total revenue. And that's what this is all about. So this is called hyperbolic, because you might remember from pre-calculus, wherever the function, whatever this is converging to the axes but never quite reaching them. We call this a hyperbola. And the formula, the equation would look something like this: y times x equals some constant k. So you could rewrite it as something like this, where that k would be the total revenues. So there's, you could express this as something along those lines. So this is another bizarre case. You don't expect to really see this in practice, but it's theoretically possible. Most of the time, we're going to get those downward sloping demand curves where the elasticity does change along the curve. Now, we also briefly discussed what are the things that change, or why do some products have such high elasticities of demand and others have such low elasticities of demand. And really, the factors that determine this come down to these three: the closeness of the available substitutes. Now, by the way, just because two goods are substitutes doesn't necessarily mean that they're close substitutes. So, for example, we could think of Coke and Pepsi as close substitutes, but Coke and, let's say, orange juice are not very close substitutes. I mean, technically they are, because they're both drinks. If you're thirsty, either one of them will take care of that problem, but they don't have a lot in common beyond that. So if the price of orange juice changes, therefore, if the price of orange juice changes, there is likely to be little or no impact on the demand for Coke. It depends on how consumers see the two products. Coke and Pepsi are different. They're virtually the same thing. Let's face it, they're almost the same. If you go to the store and Coke is on sale, you'll buy Coke instead of Pepsi. The next week, it's the other way around. You buy the Pepsi instead of the Coke. You go to a vending machine and you see that they only have Coke, so you buy Coke. Or, it's like they're practically the same thing. Very, very few people are so rigid about this that they would only choose one or the other. In fact, if you've noticed, any vending machine you might ever encounter, it's only going to have one or the other. You don't see vending machines that have both typically, because the vending machine itself belongs to one of those two companies. So like at Manhattanville, I've only seen Pepsi at Manhattanville, which means typically, especially with colleges, that means they probably came along one day and said, listen, Manhattanville College, we've got a sweet deal for you. We'll give you a bunch of money to pay for, let's say, to help pay for this, the sports facilities. And in exchange for that, you will be the only ones who have vending machines on the campus. And that kind of thing, it happens all the time. If you go to visit any college, you'll see that everything is either Coke or it's Pepsi. You do not find colleges typically that have both. It's very unusual. It means nobody cut a deal with them. Or like if you go to most schools, if you look at their football stadium, the sign probably has the name of either Coke or Pepsi on it. And that's the reason why. But if you go to a supermarket, though, of course, they'll have all of everything put together in the same aisle. And so it's obviously because the competition is so ferocious that those prices, even small changes, can trigger large amounts of substitution between the different products. So, the supermarkets know what they're doing. They keep all the like items together so that you can comparison shop. And they're hoping that you'll buy more things because of that. All right. So That's why stuff constantly goes on sales in supermarkets. They're tinkering with the prices to see how people react to it. And also sometimes they just have too much inventory. That can happen too. But it's really interesting to see how supermarkets price their products and also how they locate them. You don't think about this when you go in the store, but they have a very specific plan for where to put all these items. Like, for example, the small impulse items like candy bars are going to be at the counter, the cash register, because nobody goes to the store to buy candy bars. But if you see it and you're standing there waiting to pay, you might just throw it into your cart because it's there. And it's as simple as that. Or Tic Tacs or gum or tiny little things like that. That's why they're there. All right. Well, anyway, so the substitute goods, the closer to the substitutes that are available, the greater will be the elasticity. So with Coke and Pepsi, their demands are highly elastic because of the availability of so many other different sodas. But if you look at other types of products where there aren't really a whole lot of good substitutes, then the elasticities tend to be lower. I don't know, besides gas is a great example because there really aren't any substitutes at all. So therefore, when the price changes, you can't really do a whole lot about it. I'm trying to think of another consumer good that might have this property where there isn't really much else to choose from. It's kind of hard to imagine that because, our markets are so competitive that if a successful product comes along, naturally enough, competition will pop up and they'll try to produce their own versions. Kind of like, have you ever noticed, like with cell phones, the minute Apple has some brilliant new idea, who else already has it or is coming up with it right away too, is like the competitors like Samsung. It's amazing how they all came up with the same innovations at the same time. It's just, they're constantly watching each other to see what their competition is doing because, there's only so many people who can buy phones. And so the market is fixed and they're, really the only way they can expand their market is to steal customers from each other. But all right, anyways, so what else do we have? Oh, and yeah, gasoline, you're right. Now, proportion of your income, this is a huge deal. Clearly, if something is very expensive, you're going to be much more sensitive to changes in its prices, like we saw with the computers. Even a small percentage cut in the price could trigger a huge increase in the demand because it's expensive. 10% of a computer is a lot of money, whereas 10% of a Starbucks coffee is not much money. So the higher the proportion, the more elastic will be the demand for that product. Just because we're going to notice it more. That's the bottom line. All right, and then finally, the time period, the more time we have to adjust our spending habits, the more elastic will be the demand for all goods, okay? Especially gas. Gas is the perfect example, again, because in the long run, you can buy a better, more gas-efficient car. You can move. You can do a lot of things that you can't do in the short run. All right, now, so I think we're ready now for the next one, income elasticity of demand. So you can see the formula is very similar. What's different now is instead of having the price down here, we have I, which stands for income. It's still a ratio of 2 percentage changes, but now in the denominator, we have income. Now, the logic here being that people will change their spending habits as their income changes. Hopefully it grows. So we'd like to understand how much more people will buy of different products when their income goes up. And that's what this is telling us. Now, this one is a little bit more straightforward, I guess you could say, because we're basically here only confronting two possible situations, normal goods and inferior goods. We're just sort of lumping everything together into these two broad categories, normal goods, inferior goods. So let's take a look at how this works. And yes, the symbols mean the same thing. This is the percentage change in the quantity demanded divided by the percentage change in income. All All right, that part hasn't changed. Now, by the way, we don't, here it's a little bit different. We don't have to worry about that problem with moving along a demand curve. The percentage change can be calculated, for example, as, let me just show you how you would actually do this. And so here we don't have to mess around with the average because we're not looking at a demand curve. And then that can be rewritten as and so notice how we don't need to use the averages in here because we don't have this issue that we had with the price elasticity of demand. These numbers will be the same. And plus, we're not actually looking at movements along the demand curve. We're actually looking at changes in income over time. So it makes logical sense that we would do it this way. There's no need to have an average. Let's put it that way. So it's just a straight ahead percentage change in one with respect to the other. Okay. All right, so let me show you a quick example of this. So we're going to keep it simple. I will tell you the percentage changes. And so let's say that incomes go up 10% in the United States, and as a result, the quantity demanded of pizza goes up by 3%. So look how simple this is. So in the numerator, we have 0.03, which means 3%. Usually it's easier to turn these into decimals. And so the ratio is 0.3. So in other words, this is saying that when income rises by 1%, the quantity demanded, or actually, 3.3%. Now, that just means that people perceive this as a normal good. How do we know that? What's the tip off? This proves that pizza is considered to be a normal good. Well, the mere fact that we bought more pizzas when our income went up means that this is a normal good. All right, and that should give you a clue as to what's coming next. Like with the elasticity of demand, we can classify the income elasticity here, but we only need to compare. Really what we're interested in here is, if you notice for the first time, we're looking at the sign as well as the magnitude. Whereas with the price elasticity of demand, you'll recall that we ignored the sign and we only focused on the magnitude. Here, though, it matters a great deal whether the sign is positive or negative. So if the income elasticity of demand is negative, we call that an inferior good because that means we're buying less. Like the 87 grade gasoline. If your income went up 10%, you might buy, let's say, 2% less 87 because now you can afford the better grades. Any positive number, these are both normal goods, but we're going to further subdivide them into two categories. Between 0 and 1, we're going to call that as a necessity. And greater than 1, we're going to define that as a luxury good. Now, this is a bit of an arbitrary cutoff point, but we're going to define this as a necessity. Necessity means things that you normally buy on a regular basis anyway. all right, like food and clothes and things like that. Whereas a luxury good would be things that you might only buy if you're, you know, if things are going well for you, like an expensive vacation, for example. It may be that you've always wanted to go to Spain, let's say, and one day all of a sudden your income goes up 10% for some reason, and you say to yourself, okay, now I can really afford it, and you'll go to Spain. Whereas if your income doesn't change very much, you may never go to Spain. Whereas down here, if your income goes up even just a small amount, you might find yourself buying more pizzas or more hamburgers or whatever the case may be. So with the normal goods, there's two possible cases: the so-called necessities and the luxury goods. Okay, so let's see if, now here's an example of the inferior good. So let's say, I don't know, for example, incomes rise by 10%, and people buy 5% less grade 87 gas. So the income elasticity of, in that case, the income elasticity of demand would therefore be minus 0.05 over positive 0.10. And so that's negative one half, not two, negative a half. And so the mere fact that it's negative is what tells us that it's an inferior good. It doesn't matter how negative. As long as we buy less, it's considered to be inferior. The classification scheme doesn't have any separate, categories for negative income elasticities. It's just negative. Okay, so that's the tip-off. It's an inferior good. Of course, we only bought it in the first place because we could not afford 89 or 91. Same thing with generic drugs and, used textbooks and all the rest. Or like, I just thought of a good example. How about beef? If you've ever looked at beef in the supermarket, they rank it by the percentage of lean. And it can go anywhere from 80 to about 93, I believe. Well, guess what's different about them? The 80 grade is cheap, and the 93 is expensive. So why do people buy the 80 when it's full of fat? Because it's cheap. So imagine that you get a big fat raise at work and you've been buying 80 lean hamburger. You might switch up to the better grades. And so this could be considered an inferior good. If you're not used to shopping in a supermarket, I mean, you might not have paid attention to this because maybe you're eating your burgers in McDonald's, who knows? But if you are looking at these labels carefully, you'll see that there's a bunch of different grades available. And, 93 is, I think, as high as it goes. But, if you're used to buying 80, and you say, oh, it's time for 85 or 90, it would be because your income goes up. And I'm sure you can think of a million other examples. Now, among the normal goods, the necessities are the ones where, because this means that we're looking at an income elasticity between 0 and 1. That means that what we're seeing here is that when our income goes up, we buy more of these products, but the increase is not as great as our income increase. Okay, in other words, the percentage goes up, but not as much as our income goes up. like 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 restaurants. Obviously, a restaurant is a nice thing to eat at, because let's face it, they can make things that you don't know how to make, and they save you all the work of cooking, but it's expensive. And so, if you have a low income, you're probably not going to go to restaurants very often, even though you would certainly like to. So if let's say your income goes up by 10%, that's good. It's not a fortune. You might decide um, to go to the restaurants. Restaurant meals, we'll call it, increase. Let's say by 3%, because yes, we want to go, and we did go more often, but not maybe an enormous amount. That means people perceive this as, you can see what I mean about this classification. You might think of this as a luxury, but according to this classification scheme, is defined as a necessity because it's something you might do on a regular basis, as opposed to, let's say, that cruise to Spain. That has to be thought of by anybody as a luxury, because it's dreadfully expensive, or it could be dreadfully expensive. And so you're not going to go ahead and buy something like that unless your income is really going up pretty dramatically. So these are the luxury goods. Cruises, jewelry, especially like diamonds. When do you buy diamonds? Well, you know what? That's the kind of thing that you buy when you've got plenty of money, whereas everything you really need, you already have. So diamonds could be considered a luxury. Or how about this? Art. If you're first starting out, you're not going to plunk down $50,000 for a Picasso, are you? Well, a Picasso would be more than that. So a painting like that, why do you need it? You don't. It's not necessary. You can put a poster in your room if you have to. So, but if you start to become more and more affluent, you're going to suddenly find yourself wanting that $50,000 painting just because you can afford it. So in a case like this, we don't start to see an increase in demand until incomes really start to rise considerably. But the responsiveness then would be, you go from zero to buying no art to buying a lot of art, because your income reaches a certain level. And so as a result, the income elasticity is greater than 1. All right. So again, these are the things you don't really need. You only buy them because you can afford them. Well, this is the way we look at it here. Not that there's anything wrong with owning expensive art. It's just that, your survival doesn't depend on it. Let's put it that way. So these might be defined as luxury goods. All right, now, so the income elasticity of demand can help us identify which goods are inferior and which ones are normal. Now, I may have mentioned this once before. Sometimes the decision as to what goods are normal and which ones are inferior is not that open and shut. So economists can use this measure to separate out normal goods from inferior goods. Like if you go to the gas station and they have those 3 grades, 87, 89, and 93, what would you consider 89 to be? Is it inferior or is it normal? It's hard to say without seeing these numbers. Okay, it's possible that people will all switch to 91 if their incomes go up. We don't really know, but we can find out by calculating this income elasticity of demand. And that, of course, helps companies who sell these products to make decisions about how much to charge for those products and whether to offer them or not. All right, so you know perfectly well that some stores actually make their money because everything they offer in the store is inexpensive, like Walmart's. If you ever go to Walmart's, why do people go there? Because everything's relatively inexpensive. Even for the exact same products you can buy in another type of store, they manage to keep their prices really low. They also somehow manage to have a lot to choose from. And so they get a lot of customers coming in, and each customer provides them with a very small amount of profit, but they have a lot of customers, and that's how they make their money. A lot of the stuff they sell could be defined as inferior, but they still do very well because they can keep the prices low. And so especially when the economy slows down, that's when they really benefit, because that's when a lot of people will switch to them compared to other retail stores. On the other hand, you get the other extreme, like a Tiffany's, which only sells luxury items. I mean, they don't sell normal stuff in there, and all they have is jewelry, basically, and other very high-end items. And so you're going to sell very little merchandise, but when you do, the profit margins will be enormous. So that's their business model, the exact opposite of Walmart, which is going for volume. All right. Anyway, now we're ready for the next type of elasticity, which is cross elasticity of demand. Now, this one is used to help us identify which goods are substitutes and which ones are complements. All right. So this one, and again here, like with the income elasticity of demand, the sign will prove to be extremely important. So what we're doing here is we're measuring the responsiveness of the demand of one good and changes in other goods, the prices of other goods. All right, let's see how this works. Now here, I've got subscripts for the first time. The reason why you have to do this is because I want it to be clear that this is the quantity demanded of good X, and this is the price of good Y. Now there's another good, not the same good, which is what we had with the income elasticity of demand. The price elasticity of demand. Now we're looking at two different goods, but there's still percentage changes. And now this time we still are very interested in seeing the sign of this number. The magnitude is important too, but the sign proves to be extremely important. Okay, so let's find out. Let's look at an example of this. All right, here we go. So hamburgers become more expensive by 10%, and as a result, people buy 6% more pizza. Would that happen in practice? Of course, because hamburgers, pizza, they're both potential options, let's say, for lunch. Let's say you've got a half an hour to eat, and you go into a mall, and you're like, well, what do I have today? Should I have burgers or should I have pizza? Oh, look what happened. The burgers went up in price by 10%. I'm going to say to myself, maybe today I'll switch to the pizza. And so we find out that among all the consumers, that when the price of the hamburgers goes up by 10%, the quantity demanded of the pizzas is going up by 6%. So what does that say about our elasticity? Okay, so if you assume that X is the pizza, so you have to make that very clear. The X is the pizza, and the Y is the hamburgers. The hamburgers became more expensive, and you notice they're both positive numbers. So we end up with 0.6, which is greater than 0. Now, I think it's pretty clear that hamburgers and pizzas, even though they're clearly not the same thing, they're both potentially something you might eat for lunch, or dinner for that matter, could be considered to be substitutes. And as a result, this number is positive. So this kind of gives us a hint as to what's coming next. We're going to classify goods by their cross elasticity of demand. And so you already have a hint. Positive means substitutes. What does that tell us about negative? Well, that implies that negative cross elasticities would represent two goods that are complements. All right, so let's confirm that with our chart. That's it. All right, so in other words, if the cross elasticity is negative, we have complements. Positive means substitutes. Zero simply means they're not related to each other. So hopefully that makes sense. If you stop and think about it, more expensive hamburgers, people buy more pizzas. Therefore, the cross elasticity is positive between those two goods, and we define them as substitutes. On the other hand, if you think about burgers and ketchup, burgers become more expensive, people will buy fewer burgers, as then they will also buy less ketchup. Okay, so let's get to that example. We already know what complementary goods are. They're two goods that are consumed together as if they were a single unit. So here's an example. If coffee became very expensive, people would buy less sugar. Okay, so in other words, imagine that based on our formula, suppose that Y is the coffee and X is sugar. So based on, let's say that the price of the sugar goes up by 20%. And because of that, I'm sorry, the price of the coffee goes up 20%. And because of that, people buy less coffee, which means they're also buying less sugar. And let's just say that it's negative 0.10. So all that matters here, the magnitude is not really what we're interested in here, it's the sign. Okay, so in other words, coffee increases by 20%. Sugar, the quantity demanded of sugar falls by, let's move this down here, 10%. Not because of the sugar itself. The sugar price hasn't changed, but because people are buying less coffee, they're they're buying less coffee, so that means they'll buy less sugar. And so this ends up being negative. And that tells us that these are substitutes, complements, all right? Negative is complements. All right, negative is complements, positive is substitutes. Now, if you forget, probably the best way to think about this is to remember a couple of examples. Like, for example, with substitutes, just think about what would happen to the demand for Coke if there's a change in the price of Pepsi. Or up here, you can think of any complements you like hamburgers and ketchup. If you forget how this works, thinking of an actual example would probably help you remember which case is positive and which case is negative. That's my opinion. You don't have to do that, but I think having an example in mind could be very helpful in understanding this. All right, so oh, you know what? I forgot that this was here. So we're not completely done yet. I'll tell you why, because you know what we forgot to do? I didn't mention this earlier, but we also can define elasticity for supply. And so this is what's coming up next. So in other words, so far we've had three types of elasticities for demand. Price elasticity, which is by far the most important. We have income elasticity of demand, and we have cross elasticity of demand. But, and I neglected to mention this because I forgot that it was in here, we also can define elasticity for supply. Although usually with supply, there's only one case, and that would be the price elasticity of supply. Okay, there might be others, but we only really are interested in the price elasticity of supply. So let's see how that would work. Now, of course, this will be very different because we know that the supply curve is positively sloped. So here, this is the percentage change in quantity supplied. And this is now the change in the price of the good. Now, here's one nice thing about this. Because the supply curve is upward sloping, this number is guaranteed to be positive. We don't have to worry about signs here. This is always going to be positive. All right, so now this is not used as widely as the price elasticity of demand, but it is also important for the producer to understand how sensitive our output is to changes in market prices. So the calculation is exactly the same as we had for the price elasticity of demand, except that the sign is guaranteed to be positive. We do also have, by the way, extreme cases for the supply curve, besides the upward sloping one. Now here by the way, here we're also going to adopt this approach where we're using the averages, because the problem again is that even with the supply curve, if we try to define elasticity by moving from 1 to 2, we'll get a different result than if we go from 2 to 1. And so that's why this needs to be here. And again, it's really because price and quantity are essentially reversed from the traditional XY coordinate system. And that's why this keeps happening. So we have Alfred Marshall to thank for this, but he must have felt that, there are other advantages to having price and quantity that way. Anyway, so let's do a numerical example of this. We're back to our pizza again. Here I've got the supply schedule for you. And let's just say that initially the price is $8. And then what happens is the price of cheese drops. For some reason, it's more plentiful than usual. So the pizzerias decide, you know what, why don't we cut the price to $6? We'll sell more pizzas, won't we? Sure, maybe it'll increase our profits. So we're going to go from 8 on this chart to 6. This is P1, this is P2, this is Q1, and this is Q2 in our formulas. So you can see that they're both moving in the same direction. The lower price is accompanied by lower quantity, because now, even with the lower costs, the lower price means that we have less profit per unit, so therefore we're going to sell fewer units. So let's do the calculations. All right, so here they are. So as usual, I recommend that what you do is do this in stages, because what you ultimately want is delta Q over Q average times P average over delta P. And if you've already calculated them separately, I think that makes things a lot easier. So you notice there are two negatives in here, but they both cancel each other out. So we end up with 7 negative. Oh, look at that. It's exactly 1. How do you like that? So the percentage changes are actually the same. And of course, we do have a classification scheme for the price elasticity of supply. It's the same kind of idea. This is unit elasticity, but here what really matters is that each 1% change in price is matched by a 1% change in quantity supplied. All right, so that's how it works, at least along this portion of the supply curve. The elasticities will be different at different points along that curve as well, but here it's equal to 1. All right, so that's really all we need to say about elasticities. So this is chapter 5. Now, by the way, here's something I do want to point out. Let's go back to Blackboard for a second. This is us. All right, here we go. So if you look in each of these folders, you'll see that there's actually a problem set for chapter 3. They're not very long, but they're important. Chapter 4 and chapter 5, which we, of course, just finished. So here's what I'd like to do before I forget. Before we get too far ahead of ourselves, why don't we do this? Why don't you download chapters, the 3, 4, and 5 problem sets, and start working on them? Why don't we do this? Why don't we agree that on Friday, we'll go over the 3 and 4. In fact, why don't we look at them for a second? And you'll see, they're not terribly long. These are just meant to make sure that everyone's keeping up with the content. Here we have that discussion about the production possibilities frontier, where you're being asked to calculate the opportunity costs as you go in both directions. This, even though it looks very short, this could take a while, but it's good practice. And then for number 4, the problem set involves supply and demand. Okay, so here you're going to be asked to calculate some graphs, or do some graphs, and understand the relationships that we defined in that chapter. And then for 5, we'll just be doing a lot of calculations for elasticities. Let's take a look at that. Yeah, so literally you're just calculating elasticities and also explaining them. So why don't we do this? Let's have, let's agree that on Friday, we'll go over the chapter 3 and 4 problem set, and then we'll save chapter 5 for next Tuesday. So that way you'll have more time to work on it, especially since we just finished it. So that way, if anybody is not following along or understanding what we're doing, it'll become obvious pretty quickly. So, all right, so Friday, 3 and 4, Tuesday, number 5. All right, and they're not hard. It's exactly what we've been doing. All right, now we're going to move into chapter 7 now. Now, 7 is an interesting chapter because what's happening is that we're starting to introduce the idea that sometimes government intervenes in the marketplace and affects the supply and demand relationships. And so we want to understand why that's happening and what effect it has. But in order to analyze these situations properly, we have to introduce this very interesting concept called consumer and producer surplus. So these are fairly involved ideas. So I found a video which I think will help us with this, which I'd like to show you right now. And then when we're done watching it, we're going to look at these and do some actual numerical examples where we introduce what this is all about and how to calculate it. And then we're going to see how does it help us understand the impact of changes in the market and especially from government policies. Basically, it involves just analyzing the demand and the supply curve, but in a very specific way. So what I'm going to do is open up this video or put a link in the chat box. So we're going to watch this right now. And he's going to give you an introduction to what this is all about. And then we'll take a step back and analyze it in much more depth. All right. So now this guy has a tendency to go very fast, I've noticed. But at least you'll get a broad overview of what these two ideas are all about and what they're used for. All right. So let's try this. I'm going to put this in the chat box so you can all watch it on your own computer. All right. So let's take a look at this. Our world.
to know what you think because I don't want to be considered. Hey, Internet, this is Jacob Clifford, and welcome to my YouTube channel. Now with 60 million views,
All right, are we all done? All right. It was kind of a weird example, I think, his hair, but you get the idea. What he's trying to get at is this. Let me draw a graph on the screen here so you can see what this is all about. When we have a market like this, what we're going to take a look at here is that, let's see. All right, this will do. All right, so in other words, when you draw the traditional supply and demand curves, start with the demand curve. All right, we'll have them both. Basically, what's happening here is, let's say the vertical intercept is 20. That means whatever this good is, nobody is willing to pay $20 for this product, but somebody's willing to pay $19 for this product. Let's say that at a price of 19, there's a consumer out there who's willing to pay for it. And at a price of 18, there's two people who are willing to pay for it. And at the price of 17, there's three people who are willing to buy this product. And so it goes down all the way down. And let's say the equilibrium price is 10. And at that price, there's, let's say, 10 people who are willing to buy this product. So what happens is you've got some very happy people because the 10th consumer paid exactly what they thought this product was. Oh, I'm sorry. You're right. I forgot to turn it back on. Thank you for reminding me. You know, I turn it off when I show a video because I didn't realize it myself, but when we show videos like this on our recordings, there's always a chance that we could be violating copyright laws. So in other words, what I'm doing here is just to make sure there's no problems. I turn off the screen sharing while we're showing videos, and then I have to remember to turn it back on. So let me go take a step back and show you what I was working on. We've got our traditional supply and demand curves. And so what I was trying to show here is that here, if the price is 20, there'll be nobody buying this product. But if the price drops to 19, there'll be one person buying the product. If their price drops to 18, there'll be two people buying the product. If I charged only $17, three will buy the product. And then let's just assume we go all the way down to 10, where 10 people will buy the product. All right, so in other words, the demand curve, remember, shows the quantity that people are willing to pay for at that price. So if the market price turns out to be 10, then all the people up here are actually getting a bargain. The 10th consumer is paying exactly what it's worth to him or her. But the rest of them, the 9th and the 8th and the 7th, they're all paying less than they were willing to pay for this product. So each one of them is earning what we're going to call consumer surplus. Now you can call it a bargain if you want to, but in economics we call it consumer surplus. The difference between the price that a consumer is willing to pay for a good and the market price. There's the difference between the two, the difference between what you were willing to pay for it and the actual market price that you pay for it. So I, as an individual, if I'm this person who's willing to pay $19 for this product, I've earned a consumer surplus of $9 rather. Okay, so this consumer earns $9 in consumer surplus. Now, nobody's paying this person. It just means that they were willing to pay more than they actually ended up paying. The second consumer, they were willing to pay $18. And so we say that this person earns $8 in consumer surplus. And so you can see the demand curve essentially is lining up all the consumers from the people who want the product the most to the people who want it the least. And et cetera. I mean, we can continue going all the way down, and you can see until we get to this point, $10, this 10th consumer earns no consumer surplus because this person was only willing to pay $10 anyway. So I think you'll agree that this is actually a positive thing for the consumers. They have the opportunity to buy a product for less than they value it at. And so we're going to show a way to measure the total consumer surplus in the market for a good. We have all these individual consumers, and we can combine all these consumer surpluses to come up with a single number for the entire set of consumers. Now, it turns out that we can also do something comparable with the producer, because look what happens down here. There's one seller who's willing to charge, let's say, $1 for this product. There's another seller who would have sold 2 units at $2. And so because they have the ability to sell this product for more than they are willing to sell it for, we have on the bottom here this notion of producer surplus, which looks at the perspective of the producer. We have all these producers who would have been willing, for God's sake. Producer surplus means the difference, I hope I have enough space here, the difference between what the seller all right, I guess what I should say, you know what, let me start up on another slide. There's no way I can have enough room here. Or I'll use this slide. The producer surplus then equals the difference between the minimum price at which a producer is willing to sell a good and the actual market price. All right, in other words, and as we started to see, if there's a producer out there who's willing to sell this product for $1, and according to the supply curve, there is, but they're actually receiving $10. So this producer receives $9 in producer surplus. Okay, the difference between the supply curve and the price line here is our producer surplus. And then there'll be somebody else who is willing to sell 2 units for, let's say, $8. 2 units at $2 each. And so this one, this producer receives $8 producer surplus, et cetera, et cetera. So in my slides, I have a lot more detailed examples of this. I'm just giving you a quick overview of where we're going with this. But if you look in that appendix, you'll see there's all kinds of wonderful examples in here. And we're going to go through this, obviously not today. And when we're done, I think we'll have a much better understanding of what this is all about. And then when we start the actual chapter, you'll see why this is so important in helping us analyze, excellent examples in here, and helping us analyze the impact of government activities in the marketplace. All right, so we do have to definitely save this for Friday. Now, in the meantime, though, I want to remind you, before we do anything on Friday, I'd like to go over the chapter 3 and 4 problem sets, and then the following Tuesday, the chapter 5 problem set, just to make sure that we're all keeping up with the material and that we're all understanding it. Okay, so don't forget about that. 3 and 4, okay, and then the next week we can do 5. All right, and if you understand it, then we're in good shape. If not, well, we'll go over it again. Okay, you're welcome. I'll see you on Friday. Okay, you too. No, just hang on to it. We'll go over it together. You don't have to hand it in. Okay.